Okay, quick little lesson of what we talked about today in class. This first part is the answers for your homework. So we had linear, we had exponential. We see that linear has a constant rate of change, exponential has a variable rate of change. So that's what we would do when we compared the rates. Let's take a look at the next one. Here's what the tables look like in your answers. The graphs are just kind of sketched. You can do a printout of these notes. It's on my website if you'd like to print out to check your homework a little more carefully. Today in class we did these as a warm-up. And if we look at this, this is basically taking what we did the last unit and just doing it with just exponentials. So we did this as a warm-up. If you would like to look on page 273 in your, 272 in your workbook and try numbers 1 through 8. You can look at the note sheet and see how you did on that. I'm going to flip through them kind of quickly, so I guess you could hit pause here if you wanted to wait and see how you did. Okay, today in class we did a learning task, and in this learning task it was another review of linear. And when we take this y equals 2x and we find the values and we sketch the graph, we get this straight line. It has a y-intercept of 0, 0, and x-intercept of 0, 0. The domain range are both negative infinity to positive infinity. The function is increasing from negative infinity to positive infinity. It's never decreasing. It does not have an absolute max nor an absolute min, but we can describe the end behavior as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y approaches positive infinity. This worksheet can also be found on the website. We also talked about in class when you have a negative exponent, this may be new to some of you, when we have a negative exponent, like if we did 3 to the negative second, that just means reciprocal here, the negative exponent. So it's like the reciprocal of 3 squared, so it's 1 over 3 squared is 9. So that's how we got these terms. 2 to the negative fifth is like 2 to the fifth, and we do the reciprocal of it. 2 to the fifth is 32, so that's where we get the 1/32. So when we fill this in and we sketch the graph, we can see this is getting smaller and smaller. And if we did -6, it'd be even smaller. It'd be 1/64. And if we did to the -7th, it would be 1 over 128. It gets smaller and smaller and smaller, but it never gets to 0. Because we cannot raise 2 to a power and ever get 0. So what we have right here at y equals 0 is an asymptote. So we have a y-intercept of 0, 1, but we do not have an x-intercept because it doesn't cross the x-axis. All right, the domain is from negative infinity to positive infinity, but the range is from 0 to infinity. The graph is increasing everywhere. It's decreasing nowhere. There's no absolute max nor min because it continues forever. As x approaches negative infinity, y approaches 0. And as x approaches positive infinity, y approaches positive infinity. But we do have an asymptote here at y equals 0. The function gets closer and closer and closer as we go further left, as our x values decrease. But we never get to 0. And then the last thing we did today was we did some graphs. And I'm going to graph these again with you. Let me erase them real quick so you can see what's going on here. Okay, so we learned how to graph some basic exponential functions in class today. We're going to do more with this tomorrow. So those of you that weren't here today are not left out. We're going to go back and look at this again. And you're actually getting the same lesson right now that everybody else did. So we learned about the asymptote, and if our exponential is not translated up or down any, our asymptote is always at y equals 0. So we'll go to y equals 0, and we'll start there by putting our asymptote in. Now if we think about this, 2 to the negative 1, if I go left 1, that would be -1. So 2 to the negative 1 is 1/2. 2 to the 0, if I go left to right 0, 2 to the 0 is 1, up 1. 2 to the first, if I go right 1, 2 to the first is 2. And that gives me this graph. So I could also think of those as ordered pairs. Left 1, 2 to the negative 1 is 1/2. Left to right 0, 2 to the 0 is 1. Right 1, 2 to the first is 2. Now, the way I would like you to graph all of these is by thinking about transformations. What is the difference between this graph and this one? Well, this one's shifted down 3. So the first thing we'll do is we'll shift down our asymptote 3 units. So once we have our asymptote shifted, then we can really just look at the base of this exponential function and go, okay, I just went straight down 3. Now if I go -1, 2 to the -1 is 1. If I go left or right 0, 2 to the 0 is 1. If I go right 1, 2 to the first is 2. So all I did was I took it and I shifted it down, and then all you have to look at is your base. Let's look at this one. Shift up 1, but right 3. So when we shift that asymptote up 1, we're here now, and then we go right 3. So you can kind of think of this as like a new origin. Kind of. This is where we're starting from. So now all I have to do is look at the base. If from this point I go left 1, 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the first is 2. And then I have created my new graph. So we don't have to plug it in. We don't have to make a table. We're just looking at the base and we're shifting the function around. Now when we change the base, we're changing our moves. There's nothing added to the end, so the intercept is here. The asymptote is here at y equals 0. But this time my base is 5. So if I go left 1, 5 to the -1st is 1/5. 5 to the 0 is 1. 5 to the first is 5. And here's my new function. So another exponential function, this time I have a base of 5. So this one has a base of 5, so really all I'm doing is shifting around this function that I just drew. I'm going to shift it down 2 units, and then to the right 2 units. So I'm really kind of starting from here. My base is 5, so if I left 1, 5 to the -1st is 1/5. 5 to the 0 is 1. 5 to the first is 5. And that gives me my function. Finally, I have my last function, and it looks a little different. It hasn't been shifted up or down any, so we still have the asymptote there. But I've got a fraction here. And when I do 1/4 to the -1st, that gives me +4. And 1/4 to the 0 is 1. And 1/4 to the first is 1/4. So this one's curving the other way. And we talked about in class, why do we think it did that? Well, if you look at this base, it's less than 1. This function is decreasing. If you look at this base, it's greater than 1. This function is increasing. So when the base is greater than 1, it's increasing, but when the base is less than 1, it's decreasing. Now be sure to pull off the website your homework in addition to the classwork we did today. Your homework is the Graphing Exponential Function worksheet. Please do that for homework. Thank you.